Yesterday we learned matrix multiplication, and it was weird and different, where you multiplied a whole row by a whole column. And I would have hoped that sometimes during that you wondered, why would we do this? What's the purpose of this weird matrix multiplication? And if you wondered that, that's a good thing. You should always be wondering things like that, because there's always a reason for something. There's nothing you learn in high school anywhere that has no reason whatsoever. But sometimes it might feel that way. Like, why are we learning this? Where's the application? How does this work? Well, what we're going to look today is how we can use matrices and matrix multiplication to help us solve some problems that you could solve with your old math as well, but we can see how matrices might be able to help us. So we've got a sports company that supplies balls, bats, and gloves to different stores. So we got store P, Q, R, and S, and we have a table of how many of each thing each store has ordered. We also know the stores pay $8 for balls, $30 for bats, and $75 for gloves. I don't know if those prices are reasonable. Those seem like pretty cheap bats. But whatever, doesn't matter. Any baseball players here? No? Okay. So we want to write the total order as a matrix. So if I'm writing this order as a matrix, right, if I was cheating on the board here and I just put square brackets here and then I'd be like, I'm done. I don't have to write anything else. But if I actually wanted to write it out, I'd put square brackets. I'd write the numbers 70, 60, 50. Oops, 70 again. 50, 30, 20, 15, 40. And 22, 19, 24, 12. And one of the things, especially when you're doing applications for matrices, is you might just label this was P, Q, R, S, and we had balls, bats, which I'll add a T there, just so we can see the difference, and gloves. There's the total area, and we're going to call that matrix A. Just going to paste matrix A on this page just to save it. Paste matrix A over here just to save it. And let's go back to B. Or is there a part D? There is. I don't know if I need paste. I pasted it again. We can always make it go away. And E. Okay, well. Matrix B. Write the cost per item as a column matrix. So if I wanted to call the cost matrix B as a column matrix, that means it has one column. We have the amount that it costs here, and we have balls, bats, and gloves, and we were told the balls were 8, the bats were 30, the gloves were 75. And one thing that I'm going to point out at this moment in my labeling is I kept the order, balls, bats, gloves, the same as the order that I had chosen in my other matrix. Balls were first, then bats, then gloves. That's going to be important. So I'm going to copy this one. Whoa. And paste it here. So we have the information that we had from before. Now, using matrix multiplication, create a matrix C depicting the total cost per store. So now if you wanted to, how much is it going, if you had this data, you could figure everything out. Even mental math or with your calculator is not bad. Store P ordered 70 balls, 30 bats, and 22 gloves, right? Would it be hard to figure out how much they owe the store? No. What would you have to do? You'd have to do 70 times $8, and 30 times $30, and 22 times $75. And to find the total amount that they owe, add them together. Does this sound like matrix multiplication a little bit? In fact, we can total cost per store, we can take matrix A and multiply it by matrix B. Now, above matrix A, I'm going to write its dimensions. Can you see that matrix A was a 4 by 3? And above matrix B, I'm going to write its dimensions. It was a 3 by 1. So I'm allowed to multiply A times B because the middle numbers are the same. Okay? Secondly, you can see that I couldn't multiply B times A. It wouldn't work if I changed the order, because then the middle numbers wouldn't match. The third important thing is not only in a word problem do the middle's numbers have to match, they have to mean the same thing. So my middle numbers in A stood for B, BT, and G, and my middle number here stood for B, BT, and G. Right? And my 4 at the beginning stood for P, Q, R, S, and my 1 at the end was just money, cash. We're going to take out our calculators. We're going to enter both of these matrices into our calculators with A and B. So I'm going to go to second matrix. And although you have something in there already, when you go to edit, you can just type over top. Now I want a 4 by 3. And my numbers are going to be 70, enter 30, 22. You can just type over top of your old numbers and add your new numbers. And I'll edit matrix B. Matrix B is a 3 by 1. 8, 30, 75. I can go to my calculator, and I can now do matrix A times matrix B, and I get an answer. And that answer, the beautiful thing about matrix multiplication is we could see from our dimensions that the answer needed to be a 4 by 1. So I knew my answer was going to be 4 rows, 1 column. I also know that the 4 stood for PQRS, so I can write PQRS here as well. And I knew that my 1 stood for how much money? And although it would be easy to do 70 times 8, 30 times 30, 22 times 75, and add them up, that's not hard math. What the matrix multiplication, especially with the use of your calculator, does, 3110, 2505, oops, go back, 2810 and 2500. 2810 and 2500. What the matrix multiplication just did for us is it did a bunch of it all at once. It took this row multiplied by that column, added it up. The next row multiplied by the next column, added it up. next row multiplied by the next column, added it up, and we got all the totals for all the stores with one simple calculation. So in that sense, it's really efficient and really useful, especially if you have a calculator to do the calculations. And for most items where it's simple arithmetic calculations, calculators are great for that. Right? Why waste your time doing that by hand if you have a calculator? Unless you're on an abandoned island in the Pacific Ocean, nothing to do, then maybe you practice your math skills. I'm not sure. Okay. Now, we're going to call this one C. Something you can do on your calculator is you can hit the store button and it says, where would you like to send your answer? And I'm going to go second matrix and pick number 3C, and it will type all those numbers into C for me. So I went store button, okay, and then I checked matrix, and it's already stored in there, but I can store it over top. Number 3, which is C, I can store it as C, and it will remember that for us. Nice. Especially because now we might need to figure out some other things in part D. A 2% shipping charge. Okay, matrix D has a 2% shipping charge on top of matrix C. Matrix C was how much they had to each pay, and now you have to add 2%. Is everybody okay with adding a percentage by multiplying by 1 point and then whatever that percentage is? Did you know that mathematics before? Like when you have to pay taxes on any item, you have to multiply by 1.13 because the taxes are 13%. And multiplying by 1.13 adds the taxes on there. Actually, I mean, this is simple math, but so important to understand how simple math works, right? What does your bill say, right? You bought something that's $10. Your bill says 13% taxes is how much? It writes down $1.30. And then what does it do to that? Adds them. Right? Are you okay? You'd pay $11.30. Why is it that you can simplify this that easily? Well, if we look at this math, what have we done? This number, we take 10 and multiply it by 0.13. That's your taxes, right? And then you add the $10 originally. It's your original amount plus your taxes. Can you see that there's a 10 in common? You could factor that out. And this just becomes 1.13. So if you wanted a 2% increase, it'd be 1.02. So sometimes we can look back at some of the things that we've done. Maybe you've been told, oh, percentages multiply by 1.13, and you've just used it. But if you say, why does the mathematics work, you can figure it out. And it uses some factoring and distribution, and all those algebra skills can help you understand everyday taxes on your items anyways. Okay, sorry. So if we want to make D 1.02 times C, well, we can go to our calculator, and I can go 1.02 times by C. Again, I could do each of these separately, and it wouldn't be hard. But my calculator will calculate it for me. I had already stored things as C. 3172.2. 2555.1. $2866.2 and 2550. Yes. And this still would stand for P, Q, R, and S, and still the amount of money, but now it includes the shipping cost. Again, if I'm going to want to maybe use this later, I could store this one as matrix D. So I've got my matrix A, which is the order, matrix B, which is the cost per item, multiplied together to find out how much each store owes, added the shipping charge, and finally in part E, what is the amount owed by Burgess by each store? So I'm going to go back and steal matrix D from here. That's matrix C. There's matrix D. So there is the amounts owed by each store that includes the shipping charge. If I wanted to figure out how much money they're going to make or get in total, okay? If I want to figure out how much, I just have to add those up. If I wanted to make a matrix multiplication to add them up, total first of all, matrix, I'll just write D here. Matrix D is a 4 by 1, where the 1 stood for cash and the 4 stands for P, Q, R, and S. So if I wanted to multiply something by that to get a total, my total should be a 1 by 1. So I would need a 1 by 4 here. How many stores do I have of each one? One store of each one. If you multiplied all those ones, turned them and hit those, and added them up, can you see it would just add them up and get your total? So matrix multiplication, as we saw in just part B, allows us to figure out a bunch of information quickly. It said the total amount because it multiplied and it added. And the key to matrix multiplication, so I'm going to go back to this slide where we had slide C, is that if the numbers in the middle match up, and they match up to be the same thing in the same order. If you change the order of one of these, if you went gloves, then balls, then bats, you can still multiply them, and you can get an answer that means absolutely nothing. Has no relevance whatsoever. Bunch of numbers that are not important. So it's very important that not only do those middle numbers match up, but they match up and mean the same thing. But then the powerful thing is you can get answers, and you know what those answers mean by your outside values. So as soon as we multiplied it, we got P, Q, R, S, and how much they owed. All in one matrix together. And the balls, bats, and gloves disappeared. So let's look at the second example. Oh, find the total amount. Well, that was here. We did that where we multiplied everything by 1. We just didn't get an answer. Are you okay with not writing an answer down? Or is that going to bother you? If it's going to bother you, I think I wrote it down previously. Or I would just, okay, it didn't crash. There it is, 1114350. Complete your notes, not feel bad. Example number 2. A virus hits the school. It's nasty. Nurse Bertha, when they have school nurses, I don't think we have school nurses anymore, discovers that students are either sick, they're feeling fine, or they're carrying the virus. And she calculates all these percentages, because that's what Nurse Bertha does for the grade 11 and 12 students. And she finds out that only 15% of the grade 11 students are well, 35% are sick, but 50% of them are carrying the virus, ready to spread it to somebody else. The grade 12s haven't been hit as hard yet, but things aren't looking good. Student population, males and females, grade 11 and grade 12, are 104, 80, 107, and 103. So what we can do with this is we can set up some matrices. I mean, this matrix, grade 11s and 12s, well, sick, carrier, 0.15, 0.25, 0.35, 0.4, 0.5, 0.35. We can call that matrix A. And things are nicely set up, and I'm going to tell you why they're nicely set up right now. For matrix B, males, females, 11s and 12s, 104, 80, 107, 103. Things are nicely set up because you have a column. Notice this column matches this row. That's going to be important. I could have made that chart with grade 11 and 12 and males and females flipped, but then my columns and rows wouldn't match up. I'm going to call that matrix B. So we're going to go to our calculator and enter these all in quickly. So second matrix, edit matrix A was a 3 by 2. And 0.15, 0.25, 0.35, 0.4, 0.5, 0.35. Matrix B, 2 by 2, 104, 80, 107, 103. Use matrix operations to answer the following questions. How many males are sick? How many females are well? How many carriers are female? So again, you could just figure these things out using the data and calculating them. If I wanted to figure out how many males were sick, I know that 35% of the grade 11s are sick, so that means 35% of 104. 35% of the females are sick, so I'd have to add those up. Okay? But if I go to my matrix multiplications, and right underneath here I say I can multiply A times B, and I know that matrix A was a 3 by 2, and matrix B is a 2 by 2. And above that I'm going to write that matrix A stood for well, sick, carrier, and matrix B was 11s and 12s. Oh, sorry, well, sick, carrier, 11s and 12s for matrix A, and matrix B was 11s and 12s, and males and females. So if I multiply those, I'm going to get a 3 by 2, and my 3 by 2 is going to have well, sick, carrier, males and females is my answer. Go to my calculator to calculate that. So matrix A times matrix B. 42.35, 37.75. $79.2, $69.2. $89.45, 76.05. And with this data, now question A is really easy. I look at that chart. How many males are sick? Okay. You can't really have 79.2 sick, right? The other day when Eric was sick, all sick. It wasn't like my arm's feeling okay, but the rest of me is feeling sick. He was sick all over, right? So we would say for this one, about 79. How many females are well? Again, how many carriers are female? And so you could have figured out each of those questions by using the numbers and putting them together and adding and subtracting, but the matrix multiplication calculates all of those things together very quickly. So it becomes a very useful tool for holding information, because a matrix holds a bunch of numbers all in one. And then it becomes a useful tool for combining a bunch of information together. But the key to combining is that those middle numbers have to be the same, and they have to be the same thing in the same order. And that's why I said it was really nice that the question was set up, that when I wrote my matrices, the rows here match the columns there. It could have been that they gave you the data in the wrong order, and you would have to say, I'm going to rewrite it in this order. Because if the male and female was the column, listed in the column there, then your multiplication would mean absolutely nothing. You'd get an answer, but the numbers wouldn't help you with anything. So our third example, has lots of words and has no charts. And so you need to make up your own matrices and figure out how they're going to be and how they're going to look so that you can multiply them together. So first, you could set up this 4x4 matrix given the data that we have. And it wouldn't matter if you had the beep, it's like I'm swearing during my videos, if you had the beep on the left or if you had the beep across the top, it wouldn't actually matter. But it will make a difference for how you set up your second matrix. And for your second matrix, because you're told how much they make per day, this one I have to make a row matrix so that my beep matches my other beep. Okay? And then when you multiply the two matrices together, you would have to multiply B times A so that the beeps are in the middle. And then you'll get the beep and right answer. And our answer is per day how many transistors, capacitors, connectors, and dials are needed. So if I was using my calculator right now, I might store that matrix as matrix C. Because in question A, that's what it's asking. How many transistors are needed each day? We had that answer previously on the last one. Part B. During August and September, production is increased by 40%. How many budget, economy, executive, and presidential models were produced daily? Well, we just take matrix B, which had the totals of each kind, multiply it by 1.4. And now these ones have some decimals. So you got 14 completely made of the budget, but the economy and executive and presidential models had some that at the end of the day weren't quite finished. So now it takes 5 hours of one person working. I mean, it could take 1 hour if you had 5 people working, but that's what a person hour is supposed to represent. However many people working, it's going to take 5 hours of work to produce the budget model, 7 hours for the economy model, 6 hours for the executive, and 7 hours for the presidential. Determine the number of employees needed to maintain a normal production schedule, assuming that everyone works an average of 7 hours each day. So again, if you had read part A, lots of words, and now reading part C, lots more words, it just feels like there's a lot of data you would have to work with. However, with matrices, you can manage a lot of data easily. So first of all, I'm going to make a matrix with hours. And the question is, I could make my hours with a beep across the top, or I could make my hours with a beep across the bottom. If I want to figure out how many hours in total, I have to think of my matrix multiplication. What am I going to multiply this matrix by? I need to multiply the matrix by matrix B. Matrix B was a 1 by 4 with a beep right here. And E was a 4 by 1 with a beep right here. So I need my beep to be my rows. If I do that, it comes out to my B was per day, my E was hours. All of a sudden, I've got how many hours per day I need. And if everybody works a 7-hour day, 249 divided by 7 is 35.57, which means I probably need to hire 36 people during that month. Again, the beauty of this is how many calculations were done at once, and how the matrices could simplify that to get us answers that make sense right away. So I know I need 249 hours per day, and I need to hire 36 workers. Right? This is opposed to some businesses where they hire 20 people, and at the end of the day, they don't get enough done. So the next day, they hire more people, and then they hire more people, and they keep doing that until they get what they want done, or, oh, we hired too many people now, I have to fire somebody. So then they fire Alvin, and he goes home and cries. It's not good. So if you can figure out things the right way at the beginning, you can make better decisions. Okay, so that's exciting. I've got a worksheet for you to practice some more word problems at home.